Hello students, welcome to the second part of this comparison between automobile and earth moving machines. Myself, Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under the GIS. So today we will continue the chapter that is comparison in between automobile and the earth moving machine, which is that taken from the module number 1, and the topic title is earth moving equipment, and this topic is taken from the earth moving equipments and the farm machinery. So students, here in the previous class we discussed the traveling speed. We compared the comparison between the automobile and earth moving machine, and for this comparison we are covering the travel speed and covering the travel speed, power variation, cover the power output and power variation with the torque variation and operative condition. Now today we will continue with this part and this part. So student, let's start the today's topic, that is the second part of comparison between automobile and earth moving machines. Power variation with the speed of vehicle. During the starting of a vehicle, it has to overcome its inertia load, and as speed gains to the momentum of the vehicle increases. Similarly, the tractive effort or the torque during the starting is higher, and it reduces as the speed gain. So far the same speed of the vehicles, the output of the engine is higher during starting and reduces gradually as the momentum increases. So for the same speed of the vehicle, the output of the engine is higher and during the starting and reduces gradually as the momentum increases. The fuel consumption of the engine gradually reduces with the increases in speed. The fuel consumption of the engine gradually reduces with the increase in speed. Now coming to the next topic, that is the torque variation during the working of the heavy earth moving machines. As G1 is denoted the gearbox reduction ratio, G2 is denoted the gearbox the differential reduction ratio, and G3 is showing the reduction ratio in Excel, that is G3. So from this equation we find out the speed of the wheel equals to speed of the engine into gearbox reduction ratio into differential reduction ratio and the reduction ratio in Excel. And from here we find out the torque of the wheel equals to torque of the engine divided by the gearbox reduction ratio into differential reduction ratio into reduction gear in Excel. So in this equation you can find out the speed of the wheel and torque of the. When the heavy earth moving machinery, here the heavy earth moving machinery involves huge operation and procurement costs. So these costs are recovered through the economic operation of the plant. The tractive effort generated on the plant should be corrected in the magnitude, and this is called the rim pull. The tractive effort which is generated on the plant that should be corrected in magnitude. This is called as the rim pull, and it depends upon the power transmitted from the power plant. The power transmitted from the power plant and load of the vehicle and the traction, the load of the vehicle and the traction, ground and the ground characteristics. So this rim pull is basically depends upon the power transmitted from the power plant, load of the vehicle and traction and the ground characteristics. The crawler mounting thus produces the collar mounting thus produces better traction. The slippage or skidding of wheels or track produces loss of tractive effort and affects directional stability affects the directional stability of the vehicle and causing accident. Here is the picture of the flow of the power for the collar mounted tractor. So this one the engine section, this is the clutch, this is the gearbox section, here is the differential section, and here is the this is another clutch, here is the induction gear, the axle section, and this is the wheel. So here TE denoted the torque of the engine and NE denoted the speed of the engine, and NW denote the speed of the wheel and TW denote the torque of the wheel. So these are the power flow picture of a crawler mounted tractor. Here the power is produced in the engine and passes to the gearbox with the help of the clutch. From the gearbox to the power is provided to the differential brake, and from differential brake it provides to the axle gear hub with the help of this brake and clutch, and then it provides to the driving sprocket or the wheel. So these are the power flow line of the collar mounted tractor. Now coming to the tractive. Now coming to the tractive effort and resistance to the motion of the vehicle. Of the vehicle, the forces which is acting against the motion of the vehicle, the force which is acting against the motion of the vehicle and to obstruct the movement of the vehicle are called the tractive effort. These tractive efforts are consist of rolling and the friction resistance, which is denoted as RR. Second one is gradient resistance, which is denoted as RG, and third one is air or wind resistance, which is denoted at RA. So students, the tractive effort is basically the summation of the rolling resistance, gradient resistance and the air resistance. So this equivalence to the tractive effort, which is denoted as the R, where here, as we told, R rolling resistance. The rolling resistance is described by the equation of Kr into W, where the Kr is the constant of the rolling resistance and W is the vehicle weight. Now next one is the gradient resistance. The gradient resistance is, the equation of the gradient is W sine theta, where W is the total weight of the vehicle, and theta is the inclined angle or angle of slope to the horizontal of the track surface. This one is the theta. Next one is R A. RA is the air or wind resistance, and it is described in the equation as K A into A V square, where Ka is the coefficient of the air. These are the various kinds of value according to this. A is the frontal area of the vehicle in meter square. V is the vehicle speed. V is the vehicle speed in kilometer per hour. So these are the different types of resistance. Those are rolling resistance, gradient resistance, and air resistance. So now if we want to calculate the tractive effort, then the tractive effort is, as we know, the tractive effort is a summation of rolling resistance, gradient resistance, and air resistance. Then the tractive effort or tractive resistance is, the equation should be looks like this: K R W plus W sin theta plus K A V square. So this is the equation of the tractive resistance. Now after knowing this, we need to find out the drawbar pull. The drawbar pull, the tractive effort of the vehicle, which overcome the total tractive resistance and drive the vehicle with load for the acceleration, which is called the drawbar pull. So the drawbar pull, equation should be like that: tractive effort minus tractive resistance. This is the equation of the drawbar pull. Now coming to the problem. Here is a problem that is a dump truck weighing 60 kilonewton steam line with the frontal area of 5.6 meter square. The overall gear ratio in top and the second gears are 6.2:1 and 15:1 respectively. The transmission efficiency at the top and the second gears are 90% and 80%. The rolling resistance is 180 Newton per kilonewton of the truck weight. The wind resistance coefficient is 0.0028. If the truck is moving on level track at maximum speed of 88 km per hour, then you have to find out four things. Number one, or A, that is maximum engine power is required at the maximum speed. Number two, engine's RPM at the maximum truck speed if the driving wheels have effective diameter of 81 centimeter. Number C, the maximum grade the truck can negotiate at the above RPM in the second gear. And number 4 is the maximum drawbar pull available at the level truck at above RPM in the second gear. the problem. So from this, now find out the solution of this problem. So from this equation we find out that the weight of the vehicle, that is 60 kilonewton. Frontal area of the vehicle equals to 5.6 meter square. Then find out that overall gear ratio in top gear. If it denote the top gear ratio as G1, G1 equals to 1 upon 6.2, and in second gear ratio, overall gear ratio at the second overall gear ratio in the second gear, that is 1 by 15. Then the transmission efficiency at the top and second gear, that is 90%, 80%. So transmission efficiency at top gear, that is 90%. So efficiency of T1 is equals to 0.9, and efficiency of transmission at second gear, that is 80%, which is equal to 0.8. The rolling resistance R equals to 180 Newton per kg. Means 180 Newton into W per kg 180 Newton per kilonewton of track weight. So that's the RR equivalent equals to 180 in Newton into W. The wind resistance coefficient is denoted as Ka, that is 0.0028. Next is the truck is moving on the level track at the maximum speed of 88 km per hour. So at the top gear, the velocity is 88 km per hour. And there is also another points given, that the diameter of the wheel equals to 81 centimeter. So from that we get the radius of the wheel equals to half of the diameter of the wheel, that is 40.5 centimeter, is equivalent to 0.405 meter. So these are the given documents. Now we need to find out A, that is the maximum engine power. We are now ready to find out the maximum engine power. So to find out for the engine power, we need to calculate the tractive resistance for the level load in top gear. So if the tractive if the tractive resistance is denoted R, then it is the summation of R plus RR and RA, where RR is the rolling resistance and RA is the air resistance. Here RR is given, which is 180 Newton per kilonewton of the track weight. So that is 180 Newton into W, where 180 into W means 60 kilonewton. So from this equation we find out 180 into 60, that is 10800 Newton. So this is the equivalent of 10.8 kilo Newton. Now need to find out the RA value. RA, the equation of RA, that KA into capital A into V1 square, just because we find out the according to the top gear. So here Ka is given, that is 0.0028, 0.0028 into A. A means frontal area, which is given, that is a 5.6 meter square. So here multiply into 5.6 into V1. V1 is given, that is 80 km per hour. So into 88 square. So from here we find out that 0.0028 multiply with 5.6 in and multiply 88 square. So we find that the value of this 121.42 unit of kgf. Now we're going to multiply this 121.42 into 9.81, so we can convert it into the Newton. So then the equation is, value is 1191.2 Newton. So this is the equivalent of 1.191 kilo Newton. So from this value, so we can find out the total tractive resistance, which is 10.8 plus 1.19. So 1.19. So it is equivalent to 11 point 11.99 kilo Newton. So R at the top gear, R means tractive resistance at the top gear, the value is 11.99. And now as we know the transmission efficiency at top gear, which is the value is 0.9, and we also know that the efficiency of transmission efficiency equals to the work available work available at the track and the work done by the engine. If the work done by the engine is denoted by the P, which is the power, and the work available at track, that means tractive resistance into V. V means velocity. So from here we can find out that P equals to R V into this. So in the previous we find out the R means 11.99 into here velocity is used in the unit of meter per second. So we know velocity is 88 kilometer per hour, which is equivalent to 24.4 meter per second. So now here we put 24.4 and divided by 0.9. So from this equation we find that the power is equivalent to 325.7 kilowatt, and which is equivalent to 326 kilowatt. So this one is the answer of the first one. Now coming to the second one. The second question was to find out the second question was the engine, find out the engine RPM at the maximum track speed if the driving wheel of have the effective diameter of 81 centimeter. So we know the speed of the vehicle, the relation between the speed of the vehicle and the diameter of the wheel, that is 2 pi RW NW equals to 88 into 10 cube per 60. That's because of NW means the revolution per minute. So the velocity converted into the meter per minute. So this is the equation we can know. So from this equation we can find out NW, that is equals to 88 into 10 cube divided by 60 into 2 pi into RW. In the questions the given that the effective diameter of the wheel, that is 81 centimeter. So from here 81 centimeter is the diameter of the wheel, so the radius of the wheel is the half of the diameter, so that is 40.5 centimeter, and here you can calculate all in meter, but in the meter SI unit. So then 40.5 centimeter converted into the meter, so it is 0.405. so therefore the equation we get 88 into then Q divided by 60 into 2 pi into 0.405 equal to 576.4 RPM. This one is the speed of the wheel, and now we can find out we know the relation in between the engine speed and the wheel speed, that is G1 into N E. So from here we can find out that N E equals to NW by G1. So NW is known, that is 576.4, and G1 is known, that is 1 upon 6.2. So from there we can find out that 576.4 into 6.2 is equivalent to 3573.7 RPM. So which is equivalent to 3575 RPM. So this one is the answer of the second question, that is the maximum in the engine RPM at the maximum stack speed. Now the third question is that to find the maximum grade when the truck can negotiate at the above RPM in the second gear. So here we need to find out the velocity at the second gear. So the relation in between the velocity and the gear, that is the V2 equals to V1 into G1 into G2. So here that is equals to V1 means 88, G1 means 6.2, and G2 means 15. So from that equation we got 88 into 6.2 and divided by 15 equivalent to 36.4 kilometer per hour, and this is 36.4 kilometer per hour is equivalent to 10.1 meter per second. Now we need to calculate the R here. As we know, here the question is that to find out the gradient of the track. So the R, or the tractive resistance, is equivalent to summation of R E plus R plus R G, here where R is equal to 10.8 kilo Newton, which is find out RG is W sine theta. So from that equation you can find that as the W is 6, as the W is 60 kilonewton, then it is 60 sine theta. And now we can calculate the R E. RA equals to KA into A into V2 square, where Ka means 0.0028 into frontal area, that is a 5.6 into second velocity, that is 36.4 square. So that is, this is equal to 0.0028 into 5.6 into 36.4 square equal to 20.7 kgf. Equals to 20.78 kgf. Then it is converted into the Newton. So then multiply this 20.78 into 9.81. So we find out that is equivalent to 200 and 3.8 Newton, which is equal to 0.204 kilo Newton. So therefore the R is equivalent to 10.8 plus 0.204 plus 60 sin theta. Therefore R is equals to plus this 11.004 plus 60 sin theta. This is the equation number 1. And we know the work done in the traction, which is equal to the power of the engine, brake power of the engine, into the transmission efficiency. So from here we know the power of the efficiency, that is 326 kilowatt into, in the second gear the transmission efficiency is 80%, that is 0.8. so that the multiply of 326 into 0.8 equals to 260.8 to 260.8 kilo Newton. So this equation and this equation are equal. So this and this are equal. Once 1 equals to 2. So from this equation we can find that 11.004 plus 60 sin theta equals to 260.8 kilo Newton. So from here you can find the sin theta, that is 260.8 minus 11.004 divided by 60 equals to 4.16. And now find out the theta, that is the sine inverse of 4.16, which is sine inverse 16. Sorry, there is an correction. Uh, so work done available at the track, and the relation between the work done and this radiation, that is W equals to R into V. So here W is 260.8 equals to R is 11.004 plus 60 sin theta into V. V means second velocity in the second gear, that is a 10.1 into 10.1. So from here we can find out that sin theta equals to 260.8 divided by 10.1 minus 11.004, and then divided by this one is the 60. So then sin theta equals to 0.25. Or which is equals to 1 by 4. Or from here you can find out theta equals to sin inverse 0.25 equals equivalent to sin inverse is 14.3 degree. So the gradient is 14.3 degree. So this was the third. So students, last question is just to calculate the drawbar pull. Drawbar pull is equal to the tractive effort minus tractive resistance on the level down. So from the previous question we can find that R A equals to 0.204 kilonewton, R equals to 10.8 kilonewton, and G equals to 15 kilonewton, as the equation was W sin theta and sin theta equals to 1 by 4. So therefore, and W is the 60, so therefore the Rg equals to 15 kilonewton. So from here we can find out that TE EE equals to 0.204 plus 10.8 plus 15. So equivalent to 0.204 plus 10.8 plus 15 equivalent to 26.004, and TR equal to 0.204 plus 10.8, that is equals to 11.004. So from here the drawbar pool equals to 26.004 minus 11.004, which is equal to 15 kilo Newton. So students, here we can solve the questions. The next class will continue the comparison of the automobile and the heavy earthmoving machines. So still then, stay at home and stay safe. Thank you. Thank you so much.